special triangles. This one's called a 45, 45, 90. What do you think the 45, 45, and 90 refer to?
Angles.
Good. Angles. Okay. 90 kind of implies that it might be an angle. And then if you add these up, you do get 180. Okay, and it's a triangle. Because it's a 90 degree, we know it's a right triangle. Okay, so we have a right triangle. And if you remember from last semester, we used Pythagorean theorem on right triangles. So let's look at Pythagorean theorem. And that formula was a squared plus b squared equals c squared. And we're only going to use that once. We're not going to keep using it because we're going to have a different formula or relationship to use. And remember, we can only use this with a right triangle. Okay, so our hypotenuse is always C. That's the one opposite the right angle. The legs are A and B. The legs are the one that connect the right angle. So those are our legs. So if I give you a triangle and the sides are 5, and I want to find the hypotenuse, that's our first problem. Okay. So we would use the formula, apply it to find the hypotenuse. So we have leg squared plus leg squared equals c squared. So let's write it down. 5 squared plus 5 squared equals c squared. And then, like we did in the first semester, we would go ahead and work it out. So 25 plus 25 equals c squared. Okay. And we got to a point where this wasn't really hard. We just add these together. Okay, equals c squared. But how do we undo a square?
Square root it.
Root it. Perfect. Okay. So we're going to square root both sides and then simplify. Because we know that the square and the square root, they cancel each other. That's why we get just c. So this is one reason we were practicing on Wednesday, breaking down square roots. So this gives me 25 times 2. We know that the square root of 25 is 5 on the outside, root 2. And that would be our final answer. So our C, go ahead and write it up here, is 5 root 2. Now this has an interesting relationship. I know you guys are still writing. These sides are equal. It's kind of a curious relationship, but it works, and it works all the time. That whatever number these sides are, that's the number that goes here with a root 2. And this is why. We already saw why. We already saw why it works and how. Okay, that ends up actually being our relationship that we're going to be using. But some of you may remember from last semester, if the two sides are equal, what else is equal? If the two sides are equal, what else is equal?
The angles.
Angles opposite them. Very good. Okay, so that means that this angle would equal this one. So these would actually have to be 45. So what we're developing here only works for right triangles that have 45, 45, 90. So our summary on this is we have a right triangle that have equal sides, also known as legs. Do you remember what we call a triangle with two equal sides? It has a special name.
An isosceles?
Isosceles, good. This is an isosceles triangle with equal acute angles. Remember, acute means less than 90. So these two are less than 90 and they're equal. So they're both 45. That's how we get our 45, 45, 90 triangle because it has two equal sides. Okay. That's just kind of a summary of what we did. Let me give you a second to finish writing that. Because now we're going to jump into what does the formula look like? What does the relationship of our triangle look like? It's much like what we just talked about. Anybody still writing? Okay. If you need me to, also I can zoom out at the end of the page also. Okay, so here's the big magic formula. So draw a triangle. Try to make the legs look as equal as possible. And it's a right triangle. We're going to call, because it's an isosceles triangle, we're going to call these two sides n. They're just going to be the same number. If this one's 5, that one's 5. If this one's 18, this one's 18. If this one's 6, that one's 6. They're just the same. And this side, this hypotenuse side, even though it's just, we have a name for it, it's called hypotenuse, it's still a side. So we have n root 2. And this is the magic formula. So write this 45, 45, 90. I would encourage you to write this on the top of your homework papers, on the top of a quiz. Just always have this available so you can see the relationships. Now we're going to start to apply. How do we use this? How do we know to recognize what we're doing? So we're going to do a couple of examples, actually a few examples. So we're going to be given the fact, these are all 45, 45, 90 triangles. Okay? The whole first worksheet. On Thursday, well, next Thursday, we'll look at the second special triangle. And then on Friday, we'll combine them like a worksheet that has both of them. Okay. Okay, so this one would be, this side is 7. This is X and this is Y. Okay. So the very first thing, when I ask you, what is the first thing we're going to do? First thing that we do is label. Now, I know some of these are going to be easy, but this is part of what I want to see because honestly, there's no work to show on this particular problem. Literally, there's no work to show. There's no math to do. However, I want to see it labeled. And in the instruction box for the assignment, it says, label the way we've done in class in order to get credit. So even though there's no work to show, I want to see it labeled because there's too many ways to make mistakes. Okay, so labeling looks like we put in, and in root 2 on every triangle. We're going to do that. Okay. So then we can look for X and Y. So what do you think X is going to be?
7.
Okay. And don't forget, participation is really important. So, and I appreciate the 2 or 3 people that usually participate, but I need everybody. That's the only way I can tell if you're getting it or not. I would use the chat box option today, but I accidentally disabled it completely instead of host only. So we'll do that for next time. But I still need you to check in and try to participate. Okay, so what do you think y would be?
7 square root 2.
Yep. Because whatever n is, we're going to put that number right there. And then we put root 2 next to it. So 7 root 2, you're done. Like I said, there's no math to do in that problem. It's recognizing the relationships. If this side is 7, that side's 7, and this side becomes 7 with a root 2 next to it. Done. Okay. Here's a second example. And sometimes they'll flip the triangle on you. Let's call this one 8 root 2 x and y. So now it becomes, when they start flipping the triangle on you, you have to understand where the hypotenuse is. Hypotenuse is always opposite the right angle. So these are my legs. We have in, and in root 2. Okay, so what do you think n is going to be?
8.
8. Good. Thank you. Because what happens is, because this has a root 2 and this has a root 2, n is just the number that's sitting beside the root 2's. That's not always going to be that way. We have different scenarios, but many of them are that easy. So we know that n is simply 8. 8 and 8. So we have x equals 8, y equals 8. Done. Now, if you can't do any other ones besides these, at least feel like you've accomplished something, because you have. Okay, I need you to understand the relationships between these going forwards and backwards. It gets slightly more complicated, but it's just math. Okay. So questions on any of those? Okay. More examples. We have 4 more examples. Okay. So here's one. We'll call this one 5 root 2 x and y. Now this one's tricky because when we label, this one is my hypotenuse. So these are my legs. These are my equal ones. We have in, and in root 2. If you're not careful, our brain, being the wonderful organ that it is, will think that n would be 5, but it's not. Okay. N is all of this. So what does that make x?
5 square root 2.
5 root 2. Okay, 5 square root 2. Because these are the same. No problem. But y, when we solve for y, remember we're going to take that n, the same n, which is 5 root 2, and then we're going to put the root 2 next to it. Now we can simplify. What do we get when we multiply root 2 times root 2?
2.
We get 2.
We get a regular 2. I know some of my students are still going, okay, we get root 4, but I need you to go, we have one part gives us a whole part. This is 5 times 2, which means that y equals 10. Okay. Because I think we talked on Wednesday that like the square root of 7 times the square root of 7 gives me what?
7.
Okay, the square root of 3 times square root of 3 is
3.
okay. So we just get a regular 3. So okay, so these parts give us a whole, but that only works when they're identical. So be very careful when you're doing, problems like this, that you actually write the n and then the root 2. Let's look at the next one. This time we have 3 root 7, y, and x. Okay, what's the first thing we need to do?
Symbol them?
We need a label.
Or
Label it.
labeled, sorry.
Yeah, it's fine. That's my trick question. Then root 2, label. Okay, so we identify our n as 3 root 7. What does that make y?
The same thing, no?
Good, same thing. Okay, because these are equal. So y is also 3 root 7. But our x, and notice we don't have to find them in alphabetical order. We don't have to find x and then find y. Okay, we can find y and then x. Just be careful with that. So x is going to be our n, but we know what n is. 3 root 7. So there's my n with a root 2 next to it. And what do I get when I multiply those?
21.
Close. I know I can know how you're getting that, but what I'm gonna,
Is it 14?
yeah, but we're gonna do outside numbers with outside numbers and inside numbers with inside numbers. So because the 7 and the 2 are both inside, we're gonna multiply those together. And we'll get root 14. 3 is an outside number, so we'll leave it outside. Okay. Outside numbers with outside numbers, inside numbers with inside numbers. Okay. And thank you, I appreciate that. Not everybody had the opportunity, I think, because of last year, getting practice with radicals because of the online that we had to go to. So this might be new for some people, and I appreciate that. Okay, so we get 3 root 14. That's kind of one reason it's also important to show your work, because if I see this and then you have a wrong answer, it's like, this was the most important part right here. To me, the answer is not as important as the process. Okay. So this one, so we've got x, y. This time, our hypotenuse is 12. So this becomes a little different because the hypotenuse is now a whole number. And it can be even or odd, doesn't matter, it's the same process. The first thing I'm going to do is show you why, and then I'm going to show you the shortcut. Because it's easier to remember the shortcut if you remember why it works. Okay. So labeling, we have n, and in root 2. So anytime your hypotenuse is something other than a number root 2, if this were 6 root 2 I know my ends would be 6. But anytime it's not that, we're going to apply the shortcut. So if the hypotenuse does not have root 2, most of the time it'll be a whole number. This is what we'll do. I know that I can write an equation saying that n root 2 is equal to 12. So we write n root 2 is equal to 12. But when we solve equations and we want to get the n by itself, we know that this is a multiplication and the opposite of multiplication is division. So we're going to divide both sides by root 2. And now this looks like the worksheet we did yesterday. This is the reason we did it, because now we get n is equal to 12 divided by root 2. But I can't leave the root 2 in the denominator because that's against the math laws. So I'm going to multiply. What am I going to multiply by?
Two
What kind of 2?
square or root 2.
Yep, square root of 2. Awesome. Square root of 2 top and bottom. So on the bottom, I get a 2. And on the top, I get 12 root 2. Now that's technically an answer, kind of an acceptable answer, but ask yourself, these are both outside numbers. Can I reduce 12 over 2? And that would be yes. Okay. So I can reduce those and get 6 root 2. So we just solved and said n is equal to 6 root 2. So 6 root 2. So what does that make the other side? What would x be?
6.
But if this is in, isn't this also in? They're going to actually be the same. So x is also 6 root 2. They're the same. Whatever this side is, that one is, and vice versa. And I know that's a little uncomfortable because many of us are not used to doing that. But there really is a kind of a shortcut. Look at what ended up happening over here. See this 12? That's the 12 right here. And our shortcut ended up being we multiplied by a root 2 over 2 and then simplified. So our shortcut ends up being root 2 over 2. So we're going to write this down. If your hypotenuse is a whole number, or anything that's not a root 2, okay, put a root 2 over 2 next to it and simplify. Okay, so write that down and then put a box around it. That was important. It's not a root 2. Let me give you a second to write it down. So our last example, before we start on the assignment, let's go ahead and draw one more triangle. This time we're going to call the hypotenuse 9. So the first thing we do is label. So we have in, and in root 2. There's really only 3 applications to this whole thing. And this is the third one. If your hypotenuse is anything other than like 9 root 2, we have to apply this process. Okay, so I'm going to take this number, which is my 9. So in order to find n is equal to, take the number and put root 2 over 2 next to it. And that's going to be your answer. But then we need to simplify. Does 2 go evenly into 9?
No.
No. Good. So our n is 9 root 2 over 2. That's it. Done. So x and y are both 9 root 2 over 2. We're not going to make it a decimal because we don't do decimals with this. Okay. That was it. Any questions that I can clarify? Okay. All right, so let's go ahead and look at the assignment for today, assignment number 2. And we're going to, I've been getting through the whole thing except like 3 problems. So I'm not going to go in order. And I hope that doesn't make you uncomfortable, but because the columns, I'm going to go down on the left side, and we're going to go up on the right side. If you're drawing the pictures, I don't mind if they're out of order. They can be out of order. I'm totally fine with that. I just want them completed. Okay. So if you need me to, I can zoom out at the end of each page and you can take a picture just to make sure that you got everything accurately. Okay. Okay, so number 1. What's the first thing we need to do?
Label.
Label. Good. So remember that, especially when it's twisted, when it's rotated, it's a good idea to, like, these are going to be my legs. So this is in, and in root 2. So what does that make n?
9.
9. Good. What does that make m? So these are the same. We take it and we put it there. So what do we get?
And square root of 2. No.
So instead of the n, though, we're going to put a what?
9 root 2.
9. Good. A 9 root 2. Perfect. That's it. Okay. Number 2 is very similar. Okay, so this is n. That's n. This is n root 2. Okay, so we're going to find x and y. I actually prefer finding the legs, whatever they are. You could start with the y, you could start with the x, it doesn't matter. Because I know whatever this is. So what's y going to be?
2.
2. Good. And what does that make x?
2 square root of 2.
Perfect. 2 square root of 2. You're done. See, that's why I said some of these, there really is no math to show, and I know that. So I'm okay with it. But once we find n, we put it there. Sometimes I like to draw the arrows for my students so that they can see the relationships. Okay. So number 5, label in root 2. Go ahead and write down what I had you put it in the chat box, but we're not gonna do that right now. So N and M. You write it down. Write down what you think it is or know it is. Okay. So what's N?
Is it 4?
4. Good, because these are the same. And what does that make M?
4
4
square.
square root.
Nice. I like choral responses. If we're in the classroom, that makes me really happy because the one person that, may not have a correct answer, nobody else can really hear it, but I'm kind of trained to hear that. And I know who's getting it and who's not. So thank you. Number 7. So some of these are really easy and then they get a little bit more challenging. Okay, they're not all like this. So labeling, we have in root 2. So we're gonna write down what N is and M. Some of you are drawing the pictures, so I'll give you a second. Okay, so what is N gonna be?
And it's
Ten.
Good. Number 10.
then
They're
M
the
is 10
same.
square root 2.
And then what was M?
10 square root 2.
You're not 5.
Wait, that's a 10.
Oh, Shannon, thanks. Okay. So yeah, 10 root 2. Perfect. 10 root 2. Yep, that was it. Okay, so now it gets to the tricky part. Okay. So we're going to label. This is still in, and in root 2. Well, these are going to be the same, but I have a hypotenuse that doesn't have a root 2 in it. So we need to apply the shortcut. So I'm going to take this value, and I know that N is going to equal that number with the shortcut next to it, which is root 2 over 2. This is all I'm doing. I'm putting this right next to whatever number that is. It can be a number, it can be a root, doesn't matter. Okay. Can I simplify anything there?
Yes.
The 8 and the 2.
8 and 2.
Good. Yep. So this 2 on the bottom, outside number, goes into the 8, which is an outside number, and gives me 4 root 2. There's my N. So now that I know that this is 4 root 2, so y equals 4 root 2. So what does that make x?
Same thing.
Good, 4 root 2. That was it. Okay. So I don't want these to seem really hard because they're not. It's different. Most of you have never seen this before, and that's okay. Okay, so let's look at number 10. I'm going to go across because some people are still writing. Okay. So looking at this one, we're going to label in, and in root 2. So because I like to do these first. What's y?
3 square root of 2.
Yep. Whole thing is y. Y. That's my n. So 3 root 2. That's the same. And over here, I can plug in for x. I'm going to plug in my n value, which in this case is 3 root 2. And what do I put next to it?
A 2.
A root 2. Okay, and then I'm going to simplify. So root 2 times root 2 is what?
2.
2.
2. Good. So x equals 6. So your hypotenuse turns out to be 6. So if you have questions along the way, please make sure that you're asking, okay? Because I'm not going to stop after each one. Okay, number 8, labeling, very similar. N, root 2. Okay. You know, these are going to be the same, so what's y?
Square root of 2.
2 squared root 2. Okay, because these are, this it happens to be my n, so they're both going to be the same. So y is 2 root 2. They're going to use that n to plug in right there to find x, just like we did on this one, in number 10. So my n is 2 root 2. That was my n. I'm going to put a root 2 next to it. But what is root 2 times root 2?
2.
2. So 2 times 2, x equals 4. Some people are still writing, so I'll give you a second. Number 6 should be a little bit easier. Okay, so labeling, we have n, and n root 2. I'm going to give you a second to write down what you think u and v are. So what do you think? What's
They-
n? What would it be?
10.
It's 10. Okay, because these root 2's are the same. If I take those off, that's exactly what n is. N is 10. Okay, so n gives me 10 and 10. So u equals 10, v equals 10. Questions on that one? Some students do, honestly, they get a little confused. It's like, well, when do you know to take off the 10 and use it as an answer or multiply it by root 2? You know, and that becomes, that's where our labeling comes in. If I know that 10 root 2 is equal to n root 2, then I can just kind of like take off the root 2's and there's my n. Okay. Okay. So number 4, labeling. We have n, and n root 2. Again, our n is a radical. So we know that this whole thing is going to go for both sides. So what's y?
And and by the power 2. If oh no, sorry, 3 over 5, 3 out of 5.
Yeah.
Sorry,
Yeah.
sorry, I was looking at it wrong.
That's okay. 3 root 5, perfect. Okay. And then we know that our hypotenuse, we're going to take that in right here and multiply it by root 2. So what's that going to give me, guys?
3 root 10.
Perfect. Okay. Because these are different, we're just going to multiply them together. And this is an outside number, those are inside numbers. So x is equal to 3 root 10. Okay. Number 2, I'm going to let you do it first. N, and then root 2. So don't yell out the answer yet. Write down what x and y would be. So what do you get for X and Y?
5.
Yeah, 5.
Good. Anybody get a different answer? The answer is 5. Okay, because again, these root 2's tell me that all I need to do is select the number next to it for n. Okay, so that becomes 5 and 5. So x equals 5, y equals 5. And you're done. Okay. Second page. There are a few tricky ones on here, and I'm going to start with those and leave a couple of the easier ones for you guys. Look at 13. 13 always, you know, kind of stresses out my students because it's a fraction. But if you label, some of you need to draw it. Let me do that. Let you do that. Okay. If you label n, and in root 2, and remember, these get a little tricky when they're not in kind of the nice orientation, okay? But remember that it's the 2 that connect the right angle. Those are going to be my ends. Those are the legs. Okay? So what do you think V is going to be?
5/2.
Yep, 5/2. It's exactly the same thing. 5/2. So what do you think U is going to be?
Over
And
2.
square root of 2.
Okay. So yeah, we're just going to take this same thing and put a root 2 next to it. So 5√2/2, or 5/2√2. That's it. Whatever that is, we're just going to put a root 2 next to it. Good. Jump down to 17. Okay. Now here again, this is where our hypotenuse is not a square root. So what do we do? What's our shortcut when our hypotenuse is not a root 2? What are we going to put next to it to find n?
It will be 10.
Root 2.
Root 2 over
2.
good. Okay, so to find n, we're going to take this number and we're going to put a root 2/2 next to it and simplify if possible. And because 10 divided by 2 is a nice number, we have 5√2. That's it. Okay. So we know that x, which is my n, is 5√2. And these are the same. So y is 5√2. So there's a tiny bit of math to do in that we had to put the root 2/2 and simplify. Done. Okay. Jump over to 18, same idea, going across from it. So we have n, and in root 2. So apply the same thing that we just did to this one. And write it down. Don't yell it out yet. And do the same thing that we did on 17. What did we get for an answer? So what was your answer?
Is it 3 root 2?
Perfect. It is. Thank you for being brave enough to say that. Okay, so finding n, we're going to take that number, whatever it is, and we're going to put a root 2 over 2 next to it and simplify. So these cancel, so n is equal to 3 root 2. Good. So that makes my x equal 3 root 2 and my y equal 3 root 2. And you're done. Okay. Let's apply the same thing to number 20. So this I'm not going to give you as long. Okay. So there's n, and then root 2. Recognizing that our hypotenuse does not have a root 2 in it, the original number, we're going to apply the shortcut that we did above. Take that number, and what are we going to put next to it?
Square root of 2.
Square root of 2 over 2. Okay. When we're applying the shortcut, we have to have the square root of 2 and a 2 on the bottom. And so that'll be important to remember that this is the shortcut. We have a similar shortcut for the second special triangle. So root 2 over 2. Does 7 divide evenly by 2?
No.
No. So that is your n right there. So that makes your x equal to 7 root 2 over 2. And your y equals 7 root 2 over 2. And you're done. Okay. Let's look at number 19. Okay. This one is a little more tricky because it has a square root of 3 in it. We're going to do the same thing and in root 2. But remember we said anytime your hypotenuse doesn't have a root 2 in it, we're going to apply the shortcut. So we're going to apply the shortcut. So we're going to do the same exact thing. I'm going to take whatever value this is, and I'm going to put the shortcut next to it to find n. So we've got 5 root 3. And what does my shortcut look like? What does my shortcut look like, guys?
Is it 2?
Root 2 what? Just root 2? There's more to it than that. What goes on the bottom?
2.
The 2. Okay. 2 over 2. That is the shortcut right here, guys. So when we're applying the shortcut, it's root 2 over 2. So these are my outside numbers, the 5 and the 2. They don't divide evenly, but I can multiply my inside numbers together. So n is equal to 5 root 6 over 2. by root 6 over 2. That's my n. I know it's not a pretty number. I know it's not a nice number, like a whole number, but it is the answer. Okay, so both my x and y, 5 root 6 over 2, and you're done. So a few of these need to have some math shown, like those. Okay. Let's go back up to 16. Okay, so labeling in root 2. So I'm gonna give you a minute to work on these. Okay. Go ahead and try it. This is where I normally have you put it in the chat box, but it's not there. My fault. So what is y?
Root 2.
Root 2, because they're exactly the same. Okay, so that's root 2. But what is x?
2.
2. Good. Because we're going to take that in, which is root 2. I'm going to put a root 2 next to it. And 2 root 2s give me a whole 2. Good. That's it. So even though it's a little different, I'm hoping that you're not thinking it's like super complicated. It is a little challenging sometimes. Okay. So let's go back up to number 11. Number 11. So labeling, we have n, and in root 2. Okay, so I'm going to give you a minute. Apply the shortcut. See, this is where we need the shortcut. Take whatever that hypotenuse is and apply the shortcut and see what you get. Once you think you have your answer, you might need to do one more step. So solving for n looks like this so far. You can multiply it out and go 2 root 12 over 2, but what happens to these 2's on the outside? What happens to 2 over 2?
Would it be 1?
Mm-hmm. Yeah, be 1, or they can cancel. Okay, good. It'll give you a 1. And then we can simplify the root 6 times root 2. Most of us would just go ahead and multiply it together and get root 12, which is technically an answer, but it's not a simplified answer. Okay, so we need to break this down. And we can go 4 times 3. But the square root of 4, we could actually break it down 2 times 2 times 3. And the square root of 4 is 2. So we actually have n equals 2 root 3. So we know that both u and v equals 2 root 3. Okay. We still have 9 minutes, but I want you to go ahead and do 12, 14, and 15. And I'll be here to help if you need it. Everybody start with 14 and 15 because they're like super easy. 12, 14, and 15. Go ahead and work on those.